Right. All right. All right. What are we going to do tonight? I have to go through a workshop prep for tomorrow, and I thought maybe I'd do it online, and that way I feel like I have an audience or something. And the topics that I want to address, um, it's a 4 hour workshop. It's pretty late here. The 4 hour workshop, it's the second part. This time I'm going to go into a couple more advanced techniques. And the first thing I kind of want to talk about, I'm going to draw this here, is to consider feedback loops inside a company or like inside of your work. One of them being obviously a feedback loop of talking to the customer, right? Or the user or whatever you want to call it. And then the user asks the dev team, I'm just going to make like a factory, asks the dev team to build them something. So the build team then builds something, little app, and then you have a feedback loop where this somehow gets shown at various speeds, right? Like agile, obviously a long speed, but you get this feedback loop from the user. And I don't necessarily mean as part of the, well, no, I do mean as part of the development cycle, right? At some point, you're going to get feedback, and feedback can take, right? Like any time it takes here is going to take like a bunch of money. So any way of closing the feedback loop is going to be beneficial. And this is where LLMs come in, is that currently to build software, or like, I mean, currently, um, even with software agents, when you build a full app, so even if you have like clankers here, um, this is going to take quite a bit of time, even if you have agents and you say like, hey, I want to make like the window smaller, or I don't know what we're building. Let me make like a prototype with Claude Code, and it's going to take like 50 minutes. And maybe even if it takes 50 minutes, like no one's going to wait around for 50 minutes. So, what are ways to close these feedback loop faster? And we're going to start with the one with the customer, but there are obviously other feedback loops. Like, for example, on an engineering team, um, you might have a feedback loop where you have an RFC on how to do something, right? And then you have discussions with the rest of the team, and then it gets like reviewed. I mean, I guess there's like these time components here, right? The reviewing takes a couple of days, and then giving feedback, like, the time it takes me to address the feedback is also going to take quite a while. And then maybe someone will have another idea. I don't know what this feedback loop is here over here. Um, but at some point, you want to get like feedback on certain ideas on something that's going to be taking place on a computer. Um, and I mean, LLMs are great, but they're still pretty slow usually when you write like real software, right? Like it's hard to. I remember when I was doing a lot of like SQL and dashboards, it was impossible for me to write like a single query So that's actually another point, is like dashboards and looking at data. Data analysis is that modifying dashboards can take time, right? Until you know exactly what you're looking at. So if we have dashboards and then we have questions about the dashboards, then iterating on here is also a feedback loop where humans are involved. And then we update the dashboards and we have like questions about money. I don't know. So one of the techniques that I have to close this feedback loops is, well, instead of Rafter, which is still pretty slow, why don't we just talk about the thing that we want to build, right? And so this would be one of the techniques that you could group it as like UR, or like simulating behavior. I like UR because there's this mystical aspect to it, that whatever you tell the model as its reality, right? Like if you tell it that it's a giraffe, then it will act not giraffe, obviously, but what has been written about giraffes. So if we tell the LLM you are a data dashboard, right? Draw yourself, then it's going to draw itself. I don't know what this is actually going to do. I suspect this is going to do HTML plus SVG or something like that. It's actually an interesting thing. I've never tried to do this. Maybe it's going to build like a whole dashboard, right? But you can see this is fucking slow, right? Like now it's going to write code, and then it's going to do like a syntax error, and then it's going to fail. And like, this is not conducive to a good feedback loop, because we are not able to express our ideas fast enough to be able to iterate on them, right? It's like, I could tell you like, oh, maybe I don't even know what's going to come out. But I mean, I'm gonna leave it just for the stream because it's going to be pretty, and then I'm going to show how we get to the same result faster, because um, the good thing about these feedback loops is that if you can close them fast enough, you might, right? Like if this takes like 3 weeks or 2 weeks, if like, I don't know, if we have like a fast agile cycle and it takes like 3 weeks, and we end up with software that we don't use, then like that week was pretty much wasted in terms of figuring out, what the MVP is. But the MVP, or at least like the prototype, or like whatever the work in progress you show to your customer, doesn't need to work. It just needs to be good enough to understand that we're building the right thing. And I think it's kind of a subtle point, but it's often misunderstood, that you build these things until you ship. They're really all just questions you're asking if this is the right thing. Does that make sense? I think I'm tired as well. I don't think that makes sense. So here's a dashboard. It rendered itself. That's amazing. So what's a way to potentially start discussing things here where you're like, nah, I don't think this should be, this should be a bar graph. And like, I want the 4. Why is it always 4 in purple? I want the 4 spark lines to actually be like tables, and doing these changes, right? Like, let the spark lines be tables. This is going to take 10 minutes. It's probably going to fuck the problem up. And then I was like, no, it was good. Like we should have kept the spark lines, but they should have been like long. All of that stuff is really tedious to do. And then knowing, oh, it's able to edit the file. That's amazing. It's just fairly slow. So even on this scale of 1 hour, if we were to do this, we could probably do like 5 changes, maybe 3, 4, and it would be like, hey, fuck this. We're going to go back to our napkin. At least in napkin, we can communicate quickly. Right. And so now it made table. This actually worked. This actually worked way better than I thought. But so one way I find to do this is like, I'm going to paste a screenshot just as like a demo of what you can do. I guess you have to put a new one. So you can say like, you are a data dashboard, and then attach the image, and then we can say draw yourself as ASCII screenshot. And this is actually not the image that I wanted. This is the one. All right. Draw yourself as ASCII screenshot. No code because we don't want code. And now it's going to output kind of enough for us to discuss what we're talking about without using many tokens, right? So we can see the 4 spark lines, and then we can see, it's like kind of corresponds to this thing. And it doesn't need to be perfect for us to discuss and say like, yeah, well, maybe, maybe it would be good to have bar charts at the top, for example. Actually, bar charts at the top for this 2 minutes ago, 5 minutes ago. I don't know. I'm just making stuff up. And so suddenly, this was one iteration, right? How long did it take? Like 10 seconds. This is the second iteration. Or you can suddenly say like, hey, actually I want them all 4. I can even stop and say like, hey, hold on. All 4 next to each other. All 4 all 4 bars next to each other in 3 big sections, 5M, 2M now. Hopefully you understand that. Otherwise, you could also just like scribble and put another screenshot in there. And so suddenly we're at iteration number 3, right? And now we can start adding things, which is like add a sidebar showing history, output only sidebar. So now we can like start experimenting with an idea of like, oh, can we have like a sidebar? It doesn't need to refactor the code or whatever. It's like this is kind of enough for us to get a sense of, depending on how you design websites, to be like, yeah, this could be an idea that we could use. This is obviously way too much. So we're going to just say like, hey, make the events timeline plus drift summary, just events timeline and drift summary, filter by tags for machine clusters. I'm just making, what is this, iteration 5. So we don't need code at this moment, right? And how long you spend in here or not is dependent on, how comfortable you are with whatever prototyping technique you use. And I'll show a couple more. How well you understand each other. If the problem at hand is discussable like this, obviously, if you're going to discuss like colors, this is not going to do it. But I'll show you techniques to address that. And so now we can kind of do this, right? Where we can say like, hey, make, where now we're like far enough to turn this into some code. So another example here, because this was just dashboard, like kind of focused on a single screen. What I like doing, especially for things that are like kind of hard to describe precisely, that maybe even combine like UI and say complicated menu structures, like embedded devices, right? Like you have 2 times 16 characters and 3 buttons. So I can say like you have 2 times 16 character LCD and 3 buttons, left, center, right. You are a radio scanner. Start, output your UI as ASCII, no code. So now you can start playing with the device as if it existed. If you have MCPs in there that actually do the thing, then like, the better or not. So I'm going to do long press C settings, right? So now I can suddenly start like interacting with the device. And I realized starting with the embedded device is much better than the dashboards. I think the dashboard example is a little bit confusing. This also goes much faster. So I'm going to write that down. Example, embedded device. And so here, especially with such a constrained UI, it's like nice to have it exactly before, because this is the kind of stuff an LLM like easily messes up. Um, so now I can select the previous item, next item. So I'm going to select step size. So I'm going to say R is down, right? R, C. I can start like interacting with this thing as if it was really the the thing. Does this dashboard look like what we did? Yeah, so it has a sidebar, right? Like it has, oh, it didn't update the top level things. Why didn't it update the top level things? Oh, there it is. So it didn't remove those. Okay. Well, anyway, this kind of shows how effective this can be in the results, the look that it comes out afterwards, which can be helpful, for example, for codecs. And this whole interaction, as we're going to see here, right? Like, so now we're in scan mode normal. I'm going to say RC. No, I'm going to say like long press C back. So I can start like experimenting with being like, is long press C back is like, does it feel good? I think it does. Then I can do RRC, go to the next two down. I don't remember what it was. This was scan mode. This is going to be lock keys. Yeah, key lock. Okay, C. And then long C, right? So we're back in the scanner. And now I'm going to say hold R for 3 seconds. And I could give more detail, right? Like I'm just like playing a little bit with it. So that's exactly kind of what I want. So now make a simulator. Now that we didn't write specs, we didn't say like, hey, when you press on this menu, this, when you do, when this menu, you do this. Instead, we just like kind of play around with the device. And we kind of know at this point, like how it works is working well. Actually, that's a pretty interesting parallel to take, is that playing with things is how you learn them. And education, we talked about it last week about my operating system, or like AI in general, or like what the operating system of the future is and how important playing with LLMs is to kind of get good stuff out of them. Um, there's a good parallel here, that like playing with the device teaches you the rules of the device pretty quickly, and as such, LLMs being good at devising rules, playing with the thing until it feels good, will derive the rules that underlie this. Like that's something that I think LLMs are able to do, and as such, I think when you are a human and you go into this like planning mode, that you actually lose the fluidity of play and the fact that these rules kind of emerge because they feel natural instead of thinking about them. Uh, so that's really interesting. And I wonder, as part of my operating system, actually having playable prototypes of my devices that are integrated in the chat could work really well. So that's a side idea, but I'm going to write that down because I've got my attack here. So in Go OS, really interesting. Really, really interesting. Okay, that was a good idea. So anyway, now we have, we have this thing that's going to behave like we did a long press on C, and then if I go down and then I press C and then I have to do a long press again, it goes out, and I can do another long press, and then I can do right, like I can do this like holding thing, all of these work, and I haven't written a single line of spec. I've just like played with the device, right? So I think this is a really good example for tomorrow, to play with this, and to phrase it in like rules of play terms, right? And this is actually a book that I wanted to get. So I have a hard copy, but I think it's in Europe. Oh, what is it? MITP. Rules of play. Isn't that what I said? All right. That's the only copy? No. Oh no, the MIT press has had them taken down. All right, well, anyway. Rules of play. All right, so that was the first technique that I wanted to show, which is this like ASCII kind of simulator, simulation approach. So the next technique here is that this also applies to things that are not just user interfaces, right? And so for example, you could say like, hey, we're doing an RFC about like a new API. You are our new sales data API, right? Answer only in Markdown code blocks. So now I can just I hope that this works. I can just maybe just do like get/sales, right? And so here I can do the same thing where I can start like experimenting with it and say like, ah, no, like our data format is this, or I can do something like, get/get regions is maybe another thing we want to do. And then maybe I can do, oh, wouldn't it be cool if we had like a search parameter, right? And then I could do something like this, query APAC. I don't know if this is good. Sales about 5, 6, 4,000, 4,000, 5,000. Sorry. So you could start playing with these things and be like, hey, this is with cursor. We can start like kind of iterating with this. So, oh, do we want to have cursors or not? Is this a good idea? And then, okay, maybe we want to, what did we have at the beginning? Maybe we want to post a new sale. Make up a request body and show it to. So we can kind of start playing with the API, being like, hey, what happens if if we do this? And the LLM is like flexible enough, and especially like Claude is pretty malleable. This is kind of a little bit harder to do with GPT-5 because it tends to like be very literal. While here you want to be a little bit loose and get some ideas, and then maybe do things. I don't know what else could we do with an API. WebSocket ticker. I think this is going to respond with like WebSocket frames. Yeah. I recommend trying to do like short prompts because sometimes it's surprising and it just makes you think about what you're asking a little bit more. So Yeah, those are like ideas we could imagine, right? Where we say like, oh, we have like regions, and then we have cursors, and we have post sales with the body, and then we could say like, hey, make a simulator app, right? Um, and we can, for example, if this was Cloud Code, we could just like make a mock HTTP server that we could start like playing again even more seriously. But at least now we've like described enough of what we want without having suddenly to refactor existing code. This was enough for what we set out to do. And I need to put power in my phone. Hold on. Also, I realize I'm like, this is all taking time. I shouldn't do more than 25 minutes because the other thing I want to do is go to a ASTDSL talk that I given twice already. Let's see. This one here. And I'm going to uh, I guess I should do that on the Mac. Anyway, um, get the slides for that. But so anyway, here we have the Slayer sticker. We can like subscribe to the feed here, see these different sales, and I guess that's all I can do. Doesn't simulate. I should have said simulate the API. But you can get an idea of like things like this, how you can combine experimenting with a protocol with experimenting with this. So now we're going to get into a slightly more um, we're going to go from this like fuzzy language. Now we had like JSON, right? Like you can start combining these two, which is like, say you are a Kentucky Derby betting app, output your UI as ASCII, also output widget hierarchy as YAML, and when applicable, output SQL queries run, start, no code, just markdown. So here we're taking the ASCII and we're starting to actually add not real code, but kind of code. So you can put like, your widget names in there, and you don't need to start from scratch. Of course, you can literally be in Cloud Code or whatever and just say like, look at this header file and then this, and then it will map, the header file to the widget names and stuff like that. Like it is clever enough to do that. So now you have like your web page, and then you do have the hierarchy, and you can start like using real names and being like, hey, I think it'd be good if the badge, if we had like, if you had like a new widget like this, or maybe invent a new widget and afterwards implement it. So now you can have like a much more technical discussion of what it means, instead of just like looking at something that, ultimately is not going to look like the real thing. Is you can flesh it out, and then obviously start like really looking at backend details, for example, right? So here I chose SQL, um, but it could be like API calls, it could be like any kind of technical stuff. So output DOM callbacks, prop state bubbling as YAML DSL as well. So now I'm gonna press place bet 20. And normally, based on the previous output format and that it understands what we're doing, it's going to do the DOM callbacks, right? Like it's going to tell us all the things that are bubbling up if I had given it like a real React app. Um, but yeah, this is fucking Claude. So this was, you know, a little bit too much. Um, but you can experiment with it. And then is it going to output the ASCII? Yeah. Um, so this is really useful because now see with a couple of words and without having to do very much, without having to interact with a real app or you know, storing it and clicking and then looking at logs and stuff, you still get something that's probably really, really close and probably correct with the quality of the models these days without having to have even run it. Like you're kind of very, very close to the actual code, but it's easier to work with something that's actually not real than actually starting the real thing and experimenting with the real thing because it's just too much that's not material. Like if you look at the output of the LLM here, there's literally not a single word that isn't kind of directly related to what we're discussing, right? There's no fluff. There's no like you're absolutely correct. All of this, I mean, this one is funny, but all of this is like 100% full on the problem. There's no token that is too much here, which of course translates into like you can have a shit ton of those in your context window. Like this is smaller than a single code file, right? So with the context window sizes that we have today, you can literally go through every screen in the app probably and have like an entire specification, you know, that is like you couldn't do better. So now I could go to wallet. And yeah, I recommend you play with prompting like this. Now you go to the wallet screen. It will give you like a sense of which words work and which don't, right? Like I wouldn't necessarily have chosen the word next or something like this, right? Like I wouldn't have, there's like, I pressing show, right? Like, I mean, there's only one show here, which is another advantage of keeping everything very, very on point is that words are much less ambiguous. Um, so what this allows you to do, there's still a UI here, but we had the API before, is just basically write code. At this point, it's code, right? Like at this point, if we're developers, we don't need to really think about how to build that. It's like everything's laid out. And for the model, that is even more true. So we're getting into now an area where it becomes more and more clear that there is this gradient from informal, how we're talking, to more formal, because this is kind of formal, right? But it's not fully interpretable. It's still like kind of human. And then this obviously is a computer language. And then this is something in between. And the way I like to think of it is like basically if you blur your eyes and you remove the colon and all of those, then you or rather, if you have a human sentence and then you blur your eyes and you replace all the verbs and syntactic structure with like, you know, new lines and a dash and stuff like that, then you have this. Because really this is like the prop updates from the app to the button navbar are the prop active tab such that, you know, the previous blah blah blah. You get the idea, right? It's like it's almost English actually, and usually people who are like tech adjacent have zero problems like kind of reading this and interacting with it. Because however, even though it is still kind of like basically human language, at this point you can start like interpreting it, right? You can start like really messing with it. And this is in fact what a domain specific language is. It's something that a computer can interpret that however makes sense to people who are from that domain. And I use YAML not because YAML is the DSL, just YAML is a nice format to look at them. But you could make all kind of those. So one technique now, instead of saying like, hey, use ASCII and use this and use this, you can literally say, invent a language, yo, man, I swear to God, all the Anthropic shit is so buggy. Yo. I mean, maybe it's Firefox. Yeah, I think it's Firefox. Uh, is it you, Firefox? Yeah, it is Firefox. All right, Anthropic, you're spotless. You're I don't know why my Firefox does that, but sometimes after at some point it just gets really slow in the keys. So anyway, what's my Chromium doing? I'm compiling Chromium, and it's the third time I attempt it because I'm an idiot. All right, so invent a DSL to bet on horses. Give a few concise examples. So you can do this where you can just say like, hey, invent a DSL. As said, I like having them in YAML because it's very easy to find a YAML parsing library. And at that point, you already have like an AST, which is what we're going to get into after this. So if you're used to Lisp or Clojure or stuff like that, then that might be something you're pretty familiar with. Is like if you have a problem and you design a language to express that problem in a way that is simpler, then often the problem becomes simple, right? So if I have this kind of like DSL here, I can start kind of generating examples, right? Like 5 examples for penguins. No, for French races. So it's very easy for an LLM to generate new ones because it has a very strict structure and it's like able to repeat those, right? So maybe something we can do now is like make a simulator app. Uh, because oh sorry, make a simulator app, and then I forgot the magic words, with some presets and a drop down selector and editor on the left. Use YAML if it makes parsing simpler. I'm going to try without the YAML just because this is a test run. I'm not sure if it will work. This is not something that used to work very well. It generating like a proper parser, but it's been at least a year since I tried. Curious to see what they're going to do. So here they do have indeed the standard syntax. And then I'm curious to see, is this where it already goes south? No. Yeah, so I'm curious about this parser. Is it even recursive descent? No, it's just like fucking straight in. Yeah, I'm not all that hopeful that this will work because often this kind of stuff needs to be recursive. Like it's nice to have like a recursive descent parser. If it like probably if I told it recursive descent parser, it would like get a better sense. It does token spans. That's interesting. So maybe I misspoke. No, see the line highlighter actually is doing it in a more structured manner. That's funny. That's funny. I mean, maybe it's gonna be enough for this language. Who knows? Um, so this is taking some time. That's interesting. What should I talk about in the meantime if I were in the workshop? I could probably start like 2 side by side, have one generate the code, and then just create a couple more examples in another one. And then show how you can make a simulator, but maybe the full graphical simulator is maybe not the thing that shows exactly what this is about. Maybe one thing I can do, because this doesn't offer like a REPL, right? I wonder if there's yeah, because this takes a while. So anyway, let's go fishing for slides because I had made slides for this. And IST talk slides. And I wonder what LLM DSL, when did I write this? March 2023. This is so funny because this is exactly what I was talking about here. This is 6 years ago, 3 years ago. Jesus Christ. I wonder how much my stuff has expanded. Because this was really like the early days, like chain of thought prompting was like the hype, least to most prompting. Deciding language. Oh, interesting. Yeah, write the program to solve the problem, often easier. What did I mean by that? The loop of engineering is figuring out the query to retrieve the knowledge you need. Oh, because I was thinking about the latent space. That is interesting because that hasn't changed much either in my thinking. Yeah. Oh, man. Oh, man. This is crazy. This is crazy. This is what I was talking about this week. It's like nothing ever changes. Um, man, those are chasm of probabilistic writing. Human description. See, I'm making little stick figures again. Loop of engineering. This is crazy. Meta loop. How funny. How funny to find stuff that I wrote. Like, I'm glad that I wrote some of this. Anyway, we were going to look at the slides. I should write again in my in my vault. It's been a while. Are these the slides? Yeah, these are the slides, and then this is the handout. So what were the slides like? What is an AST? Trees in computer science. We're going to skip over that. JSON as a tree. YAML as a tree. HTML as a tree. ASTs versus parse trees. Representing ASTs in Python. Probably, I hope I can skip all of that tomorrow. Generating codes from ASTs. Using data formats as ASTs. And then the second one is like DSLs. So where do I touch upon linters and stuff? Oh yeah, create pilot rules with AST visiting. Is that in the slides as well? No. Interesting. So I wrote more in here. I don't trust that. I don't trust it. Yo. Oh, it's because I have all my CPUs are like kind of clogged. Command line interface for installation help. Interesting. Settings, enable command line interface. Settings, enable command line interface. All right. Um, AST DSL. No, open AST's DSL handout. And then here I don't say anything about Pylint. All right, interesting. So they're all in the handout. AST, Tracer, improved DSLs. Wait, where's the Pylint? All right, there's like just one little examples and then 3-sitter. Okay. So that was the next thing I wanted to talk about. I guess this is already the third part. And then the next part that becomes interesting is then maybe the JavaScript sandboxes and stuff. All right, I wonder if this is enough for me to have gone through to have a recording for tomorrow. Yeah, I think it is. This was short. I just needed to speak to myself a little bit. So there we go.